Okay, so Cantor did a proof. He showed that the set of all real numbers between 0 and 1 is uncountable. Okay, so let's go to the next page. You are not responsible for reproducing this. I'm just going to show you what it is. I'm going to explain it to you, and then you're going to have to know the results, which is that all the numbers between 0 and 1, the real numbers between 0 and 1 are uncountable. I'll come back and do this example in a second. All right, so here's Cantor's proof. So if I was to write all the numbers between 0 and 1 out, they would be these decimals, right? This would be in the first decimal place, the second, the third, right? The nth, all these decimals. And then if I was to write a list, right, to be organized, kind of like with the rational numbers, right? I would make this list here of all the numbers between 0 and 1. So for each pair of I and j, the jth digit and the ith digit, that means a sub ij. Kind of knowing what you know, right? So n sub 2 means nth row, second, moving into the second term. Okay, so here would be kind of a list of the different decimals, right? So the diagonal elements would be A11, A22, A33, right? So A11 is 2 here. A22 is 1 here. A33 would be 3 here, right? So what we're going to do is we're going to make a new decimal. Ooh, we're going to make a new number. So this is what Cantor said. He said, okay, if that diagonal entry, right, if that diagonal entry is 1, then we're going to make it 1 if the a sub 1 1 is not equal to 1. So here we go. So we're going to make the diagonal entry equal to 1 because this entry is not 1 because it's 2, right? So then here a sub 2 2, it is equal to 1, so we're going to keep it that way. No, so I'm sorry. A sub 2 2 is equal to 1. We're going to change it to 2. It was 1. Now we're going to change it to 2. A sub 3 3 was 3, which is not equal to 1, so we're going to make it 1. Moving forward, a sub 4 4 is 7, which is not 1, so we're changing it to 1. A sub 5 5 is 1, so we're going to change that diagonal thing to 2. So what did we just do? We just made up a new number, I'm going to call it just plain old D, that has this is D1, this is D2, this is D3, right? That differs in the nth position from every other number on the list. So D is not on the list, so I don't have a comprehensive list, so it's a contradiction, because what I was assuming was I can write out all the numbers, that they are countable. So we found one. He was creative and he found one that's not on the list. Contradiction. So we cannot count all the numbers between 0 and 1. All the real numbers between 0 and 1. Make sure you say that correctly. Okay, so what do we have to do? So you just get to use that result. So here's the numbers between 0 and 1, which is uncountable. So this is kind of saying make up a function that shows that this has the same cardinality. And what does that mean? I need to make up a one-to-one correspondence. So I need to make up a function between here and here. 0 to 1, 0 to 2. I know. Let's make up the function 2x, where the function goes from s to u, right? Goes from s to u, takes this and multiplies it by 2. That gets out to here. So is it 1 to 1? How do I show it's 1 to 1? I just have to show that if I have f of x1 equaling f of x2, then x1 equals x2. Check. Okay, so the onto is a little bit more work, right? So onto says I have to state, always you have to state what you're showing. So for every y in u, there has to exist an x in s such that f of x equals y. This is where we do a little bit of scratch work over here, and this is just like we did before, right? So I have y is equal to 2x, so y over 2 is x. So I say, oh, look at that. Let's pick x equal y over 2. So then f of x is f of y over 2, which is 2 times y over 2, which is y. Check. I got to the y value. I found an x, I got to the y value. All right, I'm going to add one. I thought I did, so let me just make up this an example that you are going to do. So if I'm going to have, I guess I call it 6 or whatever you want to call it. So s, which is x's in the reals, such that 0, x, 1, and then we make it v, x's in the reals, such that 0, x, 3. Okay, prove that s and v have the same cardinality. And so they'll let you do that on Zoom.